Today we travel 5 billion years into the future, following the final stages of our sun's life cycle, and uncover the brutal, beautiful, and inescapable fate of our blue planet. This is not science fiction. This is the hard-proven science of stellar evolution, written in the stars we see across the night sky, and it tells us exactly what awaits Earth when our sun takes its last breath. Let us start at the beginning to understand the end. Our sun was born 4.5 billion years ago from a giant cloud of gas and dust, called a solar nebula. Gravity pulled this cloud inward, compressing its core until temperatures and pressures became so extreme that hydrogen atoms fused together to form helium. This process, known as nuclear fusion, released a massive burst of energy that has been streaming out from the sun's core to its surface and into space ever since. For the past 4.5 billion years, the sun has existed in a stable state called the main sequence, a balanced dance between two forces: gravity, which tries to crush the sun into a tiny point, and fusion energy, which pushes outward to keep the star inflated. This balance is why the sun has remained a steady, reliable source of light for Earth, allowing life to form, evolve, and thrive across billions of years. Right now, the sun is in the prime of its life, burning hydrogen in its core at a rate of 600 million tons every single second. It sounds like an endless supply, but even the sun has a finite amount of fuel. In about 5 billion years, that hydrogen fuel in the sun's core will be completely exhausted. And when that happens, everything changes. The first sign of the sun's death will not be a dimming of light, but a slow, terrifying brightening and expansion. As the core runs out of hydrogen, the fusion process stops, and there is no longer enough outward pressure to fight against gravity. The core begins to shrink and heat up, becoming denser and hotter with every passing moment. This intense heat from the collapsing core triggers a new phase of fusion. Hydrogen begins to burn in a thin shell surrounding the dead core, instead of in the center itself. This shell fusion releases far more energy than the core fusion ever did, and that extra energy pushes the sun's outer layers outward with incredible force. Over the course of millions of years, the sun will swell into a red giant, a massive, bloated star, hundreds of times larger than its current size. Its surface temperature will drop, turning its light from bright white yellow to a deep, menacing red, but its total brightness will increase by thousands of times. This is the first catastrophic stage of the sun's death, and it will hit Earth with a force no natural disaster in our planet's history can compare to. Long before the sun swallows any planets, the heat alone will destroy all life on Earth. Right now, the sun is slowly brightening by about 10% every billion years, a gradual change that our planet has adapted to over time. But as the sun enters its red giant phase, that brightening accelerates beyond anything life can survive. In just a few million years, the sun's heat will double, then triple, then grow 10 times more intense than it is today. The first casualty will be Earth's atmosphere. The intense solar radiation will strip away the ozone layer completely, leaving the surface exposed to deadly ultraviolet and X-ray radiation. Temperatures at the equator will skyrocket to over 200 degrees Celsius, hot enough to melt lead and boil water in an instant. Our oceans, which cover 70% of Earth's surface, will not just warm, they will evaporate entirely, turning into vast clouds of water vapor that will be blown into space by the solar wind. Lakes, rivers, and groundwater will dry up, leaving a cracked, barren desert, where once there were lush forests and thriving ecosystems. All plant life will burn to ash, all animals will suffocate and overheat, and every single living cell on Earth will be destroyed. There will be no hiding, no escape, no survival. By the time the sun finishes its expansion into a red giant, Earth will be a dead, airless, waterless rock, scorched beyond recognition. But the destruction does not stop there. As the red giant sun continues to swell, it will grow so large that its outer atmosphere will reach the inner planets of our solar system. Mercury, the smallest and closest planet, will be the first to be swallowed whole, disintegrating into the sun's hot plasma and vanishing forever. Next comes Venus, our neighboring planet, which will meet the same fate, pulled apart by the sun's gravity and consumed by its fiery outer layers. And then the sun's edge will reach Earth. For decades, scientists have debated whether Earth will be swallowed by the red giant sun or survive in a charred frozen orbit. The latest research from NASA and leading astrophysics institutions tells us that the sun's expansion will be so extreme that it will almost certainly engulf our planet entirely. Even if Earth manages to avoid being swallowed, the tidal forces from the bloated sun will tear our planet apart, shattering the crust, melting the mantle, and turning Earth into a cloud of rocky debris that will spiral into the sun and be destroyed. There will be nothing left of the world we know. No mountains, no oceans, no continents, no trace of human civilization. Every monument, every city, every fossil, every memory will be erased by the sun's final violent expansion. After the red giant phase, the sun's life enters a new, quieter stage. The hydrogen shell fusion will continue until the core becomes hot enough to trigger helium fusion, a brief explosive event called a helium flash. For a few short minutes, the sun's core will fuse helium into carbon and oxygen, releasing a burst of energy so powerful that it will blow the sun's outer layers into space. These outer layers will form a beautiful glowing cloud of gas and dust, known as a planetary nebula, one of the most stunning sights in the universe. For tens of thousands of years, this nebula will shine brightly, illuminated by the hot core at its center, before slowly fading into the darkness of space. What remains of the sun after this explosion is not a star anymore, but a stellar remnant called a white dwarf. A white dwarf is an incredibly dense, small object about the size of Earth, but with the mass of the Sunday. A single teaspoon of white dwarf material would weigh as much as a mountain on Earth, compressed by gravity into an almost unimaginably dense state. It has no fuel left to burn, no fusion process to create energy. It is simply a hot, glowing cinder, slowly cooling down over trillions of years. This white dwarf will be the final form of our sun, and it will change the fate of the solar system forever. Without the sun's outward energy and heat, the remaining outer planets, Jupiter, Saturn, Uranus, Neptune and their moons, will be plunged into eternal darkness and freezing cold. Temperatures on these distant worlds will drop to near absolute zero, the coldest temperature possible in the universe. Any remaining atmospheres will freeze solid, falling to the surface as ice. The white dwarf will still have gravity, so the planets will continue to orbit it, but they will orbit a dead star, a silent reminder of the bright, life-giving sun that once existed. Over trillions of years, the white dwarf will cool down further, turning from white to yellow, then to red, then to a cold, dark black dwarf. A black dwarf emits no light, no heat, no energy. It is a completely inert chunk of stellar matter, floating silently in space. By this time, the universe will be unrecognizable, and our solar system will be a forgotten graveyard of dead planets and a dead star. The story of the sun's death is not just a story of destruction, it is a story of cosmic rebirth. The elements that make up the sun, and the elements that will be scattered into space when it becomes a planetary nebula, are the same elements that make up you, me, every living thing, and every planet in the universe. Carbon, oxygen, nitrogen, all the building blocks of life are forged in the cores of stars, like our sun, and released into space when those stars die. These elements will drift through the cosmos for billions of years, forming new nebulae, new stars, new planets, and maybe even new life. The death of our sun is not an end, but a part of the endless cycle of the universe. Stars are born, they live, they die, and they give birth to new stars in their wake. It is a cycle that has repeated for 13.8 billion years since the Big Bang, and it will continue for trillions of years into the future. As we look at our sun today, warm and bright in the sky, we can feel a sense of awe and gratitude. It is a star that has given us everything, and its death is a reminder of how small, how precious, and how temporary our time in the universe is. We cannot stop the sun from dying. We cannot change the laws of stellar evolution, but we can learn from it. We can study the stars, understand our place in the cosmos, and cherish the life and the world we have right now. For 5 billion years we have time to explore, time to innovate, time to reach for other stars, time to ensure that humanity's story does not end with the death of our Sunday. The universe is vast, infinite, and full of possibilities, and the death of one star is just the beginning of countless new stories. When the sun dies, Earth will be gone, but the legacy of our star and the life it nurtured will live on in the stars that come after. It is a humbling, breathtaking truth, one that fills us with wonder, with fear, and with a deep, abiding love for the universe we call home. The sun will die, but the cosmos will keep turning, and the story of space will never end. Please like, comment, share, and subscribe to the channel.